Welcome to Wickerson Studios. Michael Wickerson here, starting from scratch. Blank Rhino document, blank Grasshopper document, and a blank Visual Studio Code document. Now you can get started on Rhino Compute and set up your basic script, but I happen to have a folder here that I've downloaded from, I don't have this one uploaded to my site, but if you're interested, you definitely can go on to wickersonstudios.com and download anything within the full package zipped file, and anything advanced dealing with hops will give you the basic boilerplate of what you need to do, any of these hops apps. But once you get something like that, you'll be able to download it, or you can go online and get it for free off of Rhino Compute. And I have enough free stuff on my GitHub that you should be able to get the boilerplate. Once you get it downloaded, I have on my desktop a hops app py lattice live folder. I'm going to select that and open it, and it should load up everything I need right to the app, and it's all been done for us. But since this is a copy, I'm going to get rid of all this, and I'm going to show you how Copilot can write this entire script for you. You can use ChatGPT, you can use Bard, but you can use online sources and just your coding skills as well. So I'm going to take all this script, everything before the if name main, make that a little bigger. We get a little problem here. I am going to erase everything all the way up to the boilerplate, which is here, but I'm going to leave my little name, which is just my fancy way of saying what this project's going to be about. So basically, you just need this information. You don't need the comments. You just need from Flask to import Flask. You have to import the GHOps server. You will have to follow my previous videos of how to use, how to get the GHOps server up with Flask, but that's not hard. Import Rhino 3D because you'll be able to use that, because I want to do a little bit of geometry, even though I want to save a lot of it for parametric modeling in Grasshopper. Hope people find this video helpful. And then Flask app can be used for other stuff directly. And so I have an app route wrapper, little comment in there for help, and then the definition, it returns this little saying that welcome the Grasshopper hops for C Python. And you'll need this statement at the end, this if statement, to make sure you run it whenever you hit F5. And then you put in whatever you want. And what I'm going to do is show you, and I'm not going to be able to watch comments today, so I apologize for that. We're just going to record this video. What you're going to see is you're basically able to go into here, and one thing you can debug with is grab yourself a terminal, and you'll have a nice little terminal down here. I don't need to debug console, and I can run the script whenever I want. So we could hit F5, we could hit Control-S to save, and we could hit F5, and we've run the script. And it's running, and it's got a nice little IP address to send any functions from here, if they're labeled right, over to Grasshopper. And that's what we're going to do. We're going to build some geometries over here in Rhino, but we don't need to look at that right now, so I'm going to tuck it down here. I'm going to show you how easy it is, not only to script, but to really use AI as a scripting tool, where everybody's looking for ChatGPT for the answers. They're looking for Bard for the answers. I think Copilot is the answers for me. I have enough coding skills that I can debug enough, and you still have to find out all the little twists and turns as you bring it in the Grasshopper. So I'm going to set this up, and I'm going to do the most easy thing possible. I'm going to write one line of code, and we're going to step this in to more and more complex scripts as we go. So I obviously want to build Lattice over here, and I'm going to type in comment, because this is prompt engineering at its best. Write a @hops component for a simple, and it wants to build a simple adder, but I don't want to build that, lattice structure. And you could use generator. That's all I need to do. The rest of my job is tab and enter, tab and enter. And this is the automation that most novices, intermediate, and certainly skilled programmers could shift over to doing. But it's as creative and computational and parametric as you were able to work your traditional CAD, your traditional Grasshopper plugins, and parametric models from the vanilla nodes and node scripting. Before I hit that and it generates that component, I'm going to take off the solver because I don't want to run that program. Technically, I go down here and I like to hit clear once in a while, so I have a nice template. And what I've done is prepared in other files to save time, a couple things that I'm just going to bring in. And the first thing I'm going to bring in is our title page. If I can do that, I'm just going to grab it. I'm going to copy it and I'm going to put it over here and paste it in. And did it come? There it is. Creating lattices with Copilot into Grasshopper for Rhino 3D at WICKERSONStudios.com. It's going to pair with a well-noted script over here in Grasshopper. And we're going to call this one file save document. And we're actually going to go to the desktop. We're going to go to that lattice structure. We're going to go to our initial started with pandas, because we're not going to title that anymore. We're actually going to call this, actually, I still have my panda scripts in there. I don't need them in there. I'm just going to call it, what should I call it? I'll call it exactly what we just said. Lattices with Copilot. And that's it. Copilot. And that's it. We'll save that. We've got a nice little script there. And whatever we do here, we can pair it off to this Lattice Live. I probably could have called it Live or something like that. Sorry, I can't see if anybody's there. I don't have huge audiences. The other thing I might do is just what you would do is you would grab maybe a control shift tilde. This is something I do often. Shift tilde and then lattices. And that's one way to bring in your lattices. But then you got to change the size of that. So I'm just going to take this, copy paste, and then open that up and type lattices. And that's what we're going to start with, lattice scripts. And then we're going to have a little bit of a little function that I like to use right here, and I've already written it. It's basically instructions. Drag and drop a hops node in. You will have to download that. You will set the path to whatever the URL address is, and then you will call your function name. This function, we don't know what it's called yet, so we're going to use this as the call, and then we'll update what that call is. And if we so choose to label this similar to this, we can also, we can grab a scribble tool as well and paste that in, and we can tilde and paste that in and hit enter. And then we have a nice little lattice name, and that's what we're intending on calling this script. We also will probably name this script that if it works, and we're waiting to get the call path. But we need to write the function to run to this. I do know my initial one's going to output points, and I want to be able to see my data. And you can bring it out as a tree, param viewer, or you can bring it out as a panel. And I also know that I'm going to be driving these points by, I think, I'm going to hard code it in, but I'm going to treat it as a slider that I'm going to I'm going to stretch it 10 by 10, but I can also make it parametric and change those up 10 by 8, but we'll leave it as 10 by 10. And now we just have to get our function working. But that's what GitHub Copilot's trying to do for us. So if you know the framework, you look at the samples. I've spent a few months now training myself how to do hops in the Grasshopper. I think I've caught a lot of the bugs. And just a little tip when you're reading my scripts, whenever you see this little dash number after the call name, as I bring this in, we're going to start this one as lattice. And this is a new app, so it doesn't do those numbers. But what I like to know is as I debug, the biggest bug that I've found in hops is if you don't number it differently every time you have to change your script, it'll keep trying to rerun the old one. And I think that has something to do with preferences and the cached memory items. And it certainly has to do with these, or I think that it has to do with these caching memory on the server and caching the memory. So we're ready to just enter. You get the name, lattice, tab, enter, accept the description. We are not going to make icons. So I simply want to bypass icons, and you can tick through it to see what the next line is, or you can look at the documentation, which sort of exists here and there, or you can just come here and realize that this is a good tool to go from icon to just name. And I'm quite happy with the name. I use bifocals most of the time, and since these are new nodes, I don't need to memorize any icons that's happening up here. So hopefully that's a tip. So I'm going to bypass the icon by just going straight to inputs. And you'll have IntelliSense as well, but I think IntelliSense kind of gets in the way with GitHub Copilot, so I should probably take it off. But here we go. It wants to generate a hops number for me. Now, it doesn't know exactly what I want, but I can tell you right there looking at it, that X count is probably does not want to be a hops number. So you can tab it and you can accept it all, but you got to come back to where the problem is. And what you want to start learning about is what are your options? And there they are. I want this to be an integer. And as soon as it's an integer, it'll try and name it. But I'm going to call that integer quite simply size. So it's not that it does all your homework for you. And I'm going to hard code it in at 10. And one option is you can go in and hit access equals param access item. But that's for the advanced user. Since it's an item, you really don't need that. You'll go from list, and I don't work in trees at all because I take that data farther on. But that's all I want to do, and I want to end it, and I want a comma because I also want spacing. HS dot hops integer again, and spacing. It already knows I want that. I'll take the comma off because I'm through with my inputs for my node, and it will close that list. And this IntelliSense does get in the way. It drives me nuts. It will, if you back off the line and come forward, it will come to your outputs. And all I want is a hops point outputs, and it's going to say general points. And now we've built basically with development in C. And if I take that comma off, I'm happy with the points. And then I'll end it. Now it will write the definition. And this is the power of really how long a script needs to be. And I know a lot of people are stuck in Python 2.0 or Iron Python or whatever it is, because they go to the Maths tab and they use Python scripts. And that's going to do the exact same thing as what you're doing here, but with Python 2.0. And if you take a look at what I've experimented in, pretty much everything Python related and everything C related, C Unity related, and actually C Parasite, script Parasite related, which is over here. A very interesting script that updates GitHub directly to your node. So that all these wonderful plugins, you don't need any of that if you're going to go to hops. If you're going to make the big jump and realize that's the node you're going to use from now on, and everything is going to be scripted in Visual Studio Code, and you're okay with Copilot generating your ideas, you're going to be fine and set for this. So I've tried everything. I've spent so much time over the years, not too many years, but doing Copilot, doing GH-Python nodes, GH-Python remote nodes. You can see my past videos on that. Don't get stuck in it. Jump over to hops and start using the hops server. The one thing I bypassed was the loading of the hops server, which I have up and running. And that's just running a GH hops _server and Flask. You pip install that and you're ready to go. But I have past videos on that. So let's see the definition. Lattice 0001, that _01, it's going to grab your inputs and call them in small letters, size and spacing, colon for Python, indentation matters, and it writes it. Bam, all done. Everything's juicy. You've got a Rhino 3DM model in there because you're moving beyond numbers. My number one tip, really listen to me when I say this, make small functions that do very little, one operation very well. Keep it incredibly light. So you just made in one node what you would take a little bit more in grafting and points and everything visually in node scripting. We're done. We are going to save, control save, and run. We're going to grab our URL, copy it, left click double here, put in the URL, / call name Lattice01 copied, paste it in, and run. And we have now generated a geometry that is working. Our points are present, and you have in one node everything you've ever needed. Nice and easy to start. And let's just get into it and see what we could do with it. And AI will slowly make this more complicated as we go. So I'm going to grab that and put it down here. And I think what I'm going to do is just grab the script and just show you the perspective window. And for those Revit users out there, I want to have a little sensibility to them. Grab my isometric mode and make it so you can see what's happening without that distortion. So what could we do to this and consider how a lattice is built? Now, when you're learning code or learning node scripting, it's always good to just step it up a little bit after a little bit. So I'm going to grab this little guy, tuck him down there. And now go back to my GitHub Copilot and write a second structure. And this one is going to be write a hops component for simple lattice structure and generate lines. More specifically, curves. So let's see what it does. It writes a hops node, and what might be nice to clean it up is stop your script, come down here, hit clear, and let's enter. It's going to produce a lattice number 2, but since we're going from points to actually the 2, we can change the name because we're going to curves. And actually we're going to, without the trigonometry, we're going to call it lines. And it will say that's your first version of lines. So it knows we have a name, it's creating and generating lines. It knows we don't want an icon because the program's gotten smarter as we've used it. You are really coexisting with this technology. It's like being given a scientific calculator in math class while everybody else is using their fingers and toes. Your inputs are going to come in. It's going to copy the same information because I'm beginning with just 2 integer sets, which happen to be the same. I've hard coded them in as 10 just to give this kind of, instead of a name, like it wants 10. So that's just a way to make my code friendly. I don't usually do that. And the outputs are going to be curves. It doesn't matter that they're lines because lines are curves, but they're going to be between 2 points and you're going to have more of a polyline as opposed to a NURBS curve. And you'll see what we end up doing with this. And because I use subdivision over in Grasshopper or Rhino 7, it's okay. So we're done the outputs. You'll see there's no comment at the end. It ends. And that's before we see the magic here. All I'm doing is quite literally, I have in the back of my mind this urge to make a robotic by a little robot that hits tab and enter on my computer. And that's it. Like a little microprocessor, just a little servo that tab and enters. And I want to see what AI would make for me in Grasshopper and Rhino with just 1 or 2 lines of prompts. I really think I'm onto something here. I think this makes coding for those that have seen it enough but stayed with node scripting or stayed with the visualization, the CAD modeling. This should click. Your mind should just say, hey, that makes sense. Here's the definition. And it should write the points and the lines. Did it write the points and did it write the lines? Let me check with what I had in my past one. It did this before Rhino 3DM and ended it, but it left me a little space here before, which I thought was nice. And it actually went in and commented with the hashtag create the lines. So, and you could actually say create the list of lines. So you really want to be in control of your prompts. And one thing we've done here is it didn't import math. And so it's not using math yet, but I'm getting ready to use it. So there's certain things that either farther up in the script I can bring it in so it affects everything globally. And for this script, I think it's time to do that. But before I do that, for those that are need dependencies, it can't hurt to tuck in here import. It's going to import Rhino 3DM. It probably will import math because it's smart. And then I need a little comment here, create the list of points. So I'm just neatening up my code. I'm putting spaces after definitions in areas that I'm okay with. I don't count comments as code lines. But let's see if this one did what we wanted it to do. And you literally can Control save, F5 run, do exactly the same thing, which I'm going to do here. Actually, what I'm going to do is I'm going to take the name of this and correctly name this. I'm going to correctly name this one as the call function. And I'm actually going to give people some instructions. And I don't think there's any format for this. This is just what I've come up with at Wickerson Studios over the months. But now I can grab all of this, copy it down, get rid of my script I was running, grab this comment, come over here and change it to the next one, which will be lines. Actually, I made a mistake because this is lattice 1, and somebody should have caught me on that. It should say points. This is lattice 1, and this is lattice 1s. So it's easy to make mistakes when you're going live. It's easy to make mistakes while you're alive, and that's totally okay. So now we have this one, and we've got this call function. We have the URL. I'm going to copy that, drag down my hops node, which the instructions say, double left click, set my URL, full forward slash, copy the call name, and bamf. From the same two numbers, if I just want to put this in, I can. If I put in my numbers, it should go to a beautiful color, which always feels good. Of course, I can't force it through points. So we know we're in the lines or curves, so curves are more inclusive than lines. And we have line-like curves. And we actually have a big solid list, no tree data yet. But that's just the nature of what came out. Let's take a look at what we generated. And there it is. So there you go. You've got the beginning of lattice that is coming from these points and generating this. But we've also realized this script is obsolete now. So let's prepare to write another one. So we can copy, paste, slide it down. We're going to be changing this and changing these names in a minute. And we'll see what we can actually produce. So this is a longer tutorial, but I want to go slow and consistently. So what would be the next thing I'd want to advance this and give a function that steps up on that one? I am going to just quickly double check. I am going to do something that I think is much more interesting. And of course, I love math. So write a hops simple lattice structure with, I'm going to stop here with generating curves. I'm going to say with a slider, it's saying, no, with three-dimensional trigonometric points. So we're going to start with that one and see what it ends up doing. It will write my component, and this is where it gets wise. So this is trig1, lattice trig1, and I should make this a little bigger. Sorry, I shrank it. Name lattice trig. Create a simple lattice structure with 3D trigonometric points. Inputs. It wants the same size input. It wants the same spacing. It wants to give me an output of points again. So obviously this has got to change. And I can draw down my point and anticipate what's coming out. I can also anticipate the name of my new function. And if I don't make an error, it should be all right. Trig lines. And like I said, this is a little tedious. I should automate it a little bit. Let's see what it wants to give me. Close up that node, which we just created from hops component. It just wants those two parameters, those two arguments. And it writes the Rhino 3DM, the math, and take a look down here, math sign spacing times, 1 second. Let me see what else it generated for me. And of course, I unclicked it. You could see exactly what it did here and threw it at the end. It threw in a little bit of cosine this time instead of sine. And actually, I like cos more than sine. And then we've got some set amplitudes and things like that. It's not exactly what was written into my last script and what I was playing with, because I wanted to involve some amplitude and I wanted to involve some frequency. So what I might do is take a step back, even though this is going to produce something very interesting. I see that something's going on here. So I'm going to call it all the way back up to here and anticipate with a comma another tool. And there it is writing it for me. The amplitude of the trigonometric axis, and it's setting it to 1, but it becomes parametric. It just has a hard code if I don't input something. And then a frequency. And the comma is over, so now I've complemented my script. And because I haven't run it yet, I haven't saved and run it, it's okay to use the same name on your hops node. And a lot of people don't know that. So it's going to produce points, and we are going to write that function again with the amplitude and frequency inputs, arguments. So bam, it writes it. It's a little bit cut off, but you can guess at what it's writing. I just don't want to slide it over. We've returned the points. It's ready to do something more with those points, possibly curves. Let me slide over so you see the full script. There it is. And now I'm going to hit Control S, save, F5, run, select the URL, Control C, copy. The only problem is now I lost my hops node, so I'm going to pull that back out. I am going to double left click, set my path, / call my lattice trig, copy it, paste it, and now I have my 10 values. I have my amplitude, which it wants to set it at 1, but I'm going to be a little savage and set it to 4. And I actually realized it's a hops number and a hops number, which allows me to edit this to a rational number. And my frequency, I can do the same because it's a hops number. And it did not run. And this is the fact of bugging and debugging. What did it do and what is its problem? It says right here, must be a real number, not a list. So where did I have it set up? This is when things start to run into problems and people get a little frustrated. And I don't mind it happening, but let's see if I can hammer through the details of this. And this is where it becomes good to rename your script. 2, second version, rename your definition. A lot of people don't know how to do this, and this was just trial and error. So I'm going to go in here and I'm going to start specifying my axis because that's what's giving me trouble. Access equals parametric hops param access list. I can do the same for this because it's okay as a list, as an item. And this is where many people just don't know this, and I don't know how you would learn it outside of just trying to find evidence online of other people's scripts and then using it. I am going to go to the amplitude, and I want to make these items as well. So it's getting to be a little long off my page, but if I prime it with access, I can double check that says list in a minute, item in a minute. And we'll just slide off and see what that one's reading as. And they're both items, so that's good. And then I am not specifying my input back. My output is actually, you gotta be careful on this stuff. I want this to be outputted. I hate that IntelliSense. It's driving me nuts, do-si-doing around. Access list. Now this may solve my problem, and I had to rerun it. I think everything else as I go down, I will just extend it a second here and double check that I have my range, my size. I just want to generate points. I'm using Rhino 3DM, point 3D. I have I times spacing, J times spacing, amplitude times the math of sine of the frequency times I times spacing. And I'm not even going to bother with that because it's not really that necessary. If you take it out, it'll work the same for you. It could be kind of fun to add it in, but I don't want to complicate things. I'm going to hit Control S to save, F5 to run, and I messed up a syntax, probably because I took that last bit out. Where is my error? Bracket, blue bracket. Why am I having trouble with sine of frequency? That's interesting. It's line 92. There's something wrong with this. Let's go back. See if I have a problem with that one because it wrote it. And something's up with my axis, and I think I know exactly what it is. It's a small thing, and this is what's frustrating with this. The axis that... I need to extend this. No comma there. There is a comma there. My access is going through all the way. It's not 92 that's causing the problems. It's this one that's causing the problem. And I'm curious why that is having trouble. Let me grab another script here on 92. kind of cheating here because I want to know what's going on exactly with this. I think maybe it's off the page. Let me just try this again. Okay. Get init param argument access. Maybe I spelled access wrong somewhere. 80 in the module line 80. There's a problem. Let's go back to 80. Access. Param access. Where is my problem? Let me hit this one. Could be that my, it's curious. Access item. Where is my problem? Hops number. Well, I hate to slow down, but this is where people get a little, I'm going to take out my, I don't really even need that hard-coded in as one. It's not like I'm doing anything by unit. Item, amplitude, frequency of trigonometry. Very strange. Got a bug here that I'm just not finding. But it worked. So I must have debugged it with that strange function did not want that hard-coded one in there. I didn't use it before, so I shouldn't have used it now. So you have to know how to program enough, and you just have to think of it like Thomas Edison. Just keep solving it until it works. And the more errors you make, the closer you're getting to the right answer. And a lot of people just can't tolerate that. So that's why I'm making these apps and sending these apps out. So let's shrink this a little bit. I don't want to cut off anything too much. But you get the sense of it. I'm going to grab that hops node. I'm going to paste in my URL. I'm going to do my call lattice, and I'm going to drop it in and run it. And I'm able to take my 10, my amplitude 4.0 and frequency. It works. I generate points. I've got a new call name, and I had to change it every time I have a bug. So it took me 2 tries, and actually took me a few more if you look at the trouble I was having. I'm going to take off my cache server and cache memory. I'm going to put in the name and paint it so I don't need an icon. And I'm going to take a look at what I generated. And there you go. You have gone from boring flat points to boring flat lines to very exciting points that you are now gaining some control over that you could have done. But Copilot will kind of write this for you. And you can see that you imagine what this is starting to do as a lattice as I move through it. Or the amplitude if I want to extend that amplitude up. Or if I want to shorten it in one direction or lengthen it. It's a one-piece node. And you can imagine that here I could just cheat and say, and it's always good to do this, say grab a NURBS curve and run these through and see what your curves look like. Now, that's a very strange curve that I might geometrically want to build a lattice out of, but that's not really what I want to do. I'm going to grab a polyline and take it here and see what that ends up doing. And that generates something very similar too, but just the straight edges. And I'm okay with that right now. It seems kind of fun that would be, and you can see that it kind of jumps and twists and turns, and it's always good to have a couple of views, but that's not really what I want yet. I want my lines to come out similar to this being gridded like this and maintain its structure, its list structure. So let's see what we end up doing if we carry this one step farther. So let's copy this again, copy and move it down. And this is where you end up making your list. You keep a little bit of fun, you keep a little bit of creativity. That's the key to it. And you let things play as you go. I'm going to eradicate this one. That's the trig. This one's going to change its name. I'm going to downsize my Rhino. We got a little stuck there in the middle, but where else are you going to see how to debug? So this one, as we go through, I'm going to ask this to write a hops component with trigonometric points into curves, which is exactly what I did on the last one. Let's see if we run into the same problems. I'm going to make sure it lines up. This is going to be trig lines, and we're going to call it trig curves. And we can call that, I think, -1, because we haven't named anything trig curves before. We called it lattice trig, but we didn't call it lattice trig curves. So let's see what ends up generating. And nobody's going to do this for you, but you're going to debug it's just nice to lighten everything and get things moving a lot faster. So lattice trig curves, create a simple lattice with points into curves. Inputs will be, let's see the same. It knows to cut short these into items from integers. It knows these are numbers. It knows to get rid of that hard-coded 1.0, knew to get rid of that hard code. We've ended those scripts. We're going to have an output that will come out as curves now as a list. And we are just plugging through this and waiting for the definition with those attributes. So with any luck, we'll hit this on point. And let's see if it does it. I'm going to click through and see if I get similar script or not. And what I want to do, it didn't have to import the Rhino 3D. It did choose to put the math into this spot. It didn't give me a nice comment of what it was doing. So prime it to tell you the comment. When you're done with those points, when I finish those points, it definitely wants to generate the curves for me. And it's always nice to space that because you want things to be readable. I don't follow the pip or Python 18801 or whatever the hell it is. I can't remember. This one looks about right. The size stepping, the curves coming out, the lines are curves in this script, and I'm using the math, and it's going to do what I was kind of playing around with here, but I've nested it back into Visual Studio Code and kept my scripts incredibly light, incredibly simple, and you can hand somebody an operating system with parameters that's a single node. That paired with this incredible tool is the bomb. And if you don't know what I'm looking at there, and you don't know how to make plugins, the first plugin you'll make is probably bifocals. That is the subdivision multi-pipe tool. And for anybody fighting with mesh or fighting with NURBS over the years, little multi-pipe goes a long, long way. So we also have to get rid of this and anticipate we'll need curves. So I'm going to grab a little container here. And we're going to prepare those curves not only for here, but also for the curves going into that subdivision tool when we're done. But we're getting awfully close to finishing this up for now. But I'm going to do one more thing when I'm done. And it's going to get a little fancy. One thing I wanted to show as I did this and stepping it up, there's some fun things you can do with that. And I just want to get you ready to think about that as you go into the frequency. One thing I didn't do here, and I just want you to anticipate, anybody playing with this, it's not great yet. I'll show you it when I make the curves. It's a little hard to see what's happening when it's just points on the board. But a lot of us who are computational, in my mind, really are able to see multidimensional arrays and data trees and these things as our geometry. So what we actually envision, the logic we're looking at isn't really the logic that isn't really the visuals that people see in Rhino environment. That maybe is getting a little too complex to think about things that way, but that's how I think about things. Let's stop it. Let's Control S to save, F5 to run. Let's take our call. Let's pull down our one hops node. Let's double click on it, put the URL in, and that is grabbing the function name, posting it in, lattice trig curves, and we're ready to go. And I want to show you a little trick with this one. If it loads, it's always exciting to put your last node in and then see it goes green. So those curves are coming. We're able to take a look at what we have, and there you go. You got a very nice, controllable, beautiful grid that's doing exactly what you want, waving and behaving, and you can put that through an animation. If that's moving so fast, you'll see there's no slowdown on anything. I like things under 100 milliseconds, but that's a very interesting subdivision tool. And if we cap it, we can use that to Boolean difference and build meshes to cut out of things and use for any type of production. And that's where it gets insane. So I'm going to hard code in a 2 here, and I'm going to basically prepare for a single subdivision that can go, that's a subdivision with 1,890 faces. Pretty amazing piece of geometry, watertight. But what we're going to do is disconnect that for now, so we're moving incredibly fast. We're going to take that name. I'm basically going to do a little thing here that I have the name, and I just want to grab it for a second. Lattice, sorry, I have to grab the right one. Lattice 3D, it's behind here. I have to remember where it is. Lattice trig curves -01. Let's name it that, just for good documentation. Let's have the call name right. Lattice trig curves, calling it right, so people know what to do when they come blind to your Grasshopper script. And if you do things consistently, certainly within a business or a small group or a small project, everything will run smoothly. But I wanted to show you something because as we play with this geometry here, I'm a sucker for free play. I'm a stone carver. I'm a bronze maker. I don't follow any rules. I'm not out there to impress anybody. I have nothing to lose. I'm creative. I'm chaotic. I know exactly who I am. And what I can do is instead of saying, hey, look at all those iterations, why don't I just grab that wonderful range tool, which is just the bomb. Put that in as my domain. Let my steps be hard-coded as maybe 2 to start. And let's step that up into 2 patterns and get 2 meshes. And there we go. Now you see your lattice coming together. Now you see your lattice having to behave with 2, no matter how simple it is, as it moves from one type of lattice structure to 2. And as that 2 goes, I can make 3, I can make 4, I can make 5, I can make 6, I can make 10. You can end up building some pretty cool, fast-paced geometries. It's not so beautiful yet, but you'll see what I'm doing in a minute. I am going to grab that, put it in my curves node, make a subdivision that's just killer. I actually might flatten the data. We're up to 240 milliseconds, and we've got a few errors with it. And I have to wonder why I'm getting errors with it. Probably too convoluted, too complex. Let's just see if I can calm it down. 5 is about where the subdivision starts to say no more, and you get these fancy extensions. So I've pushed this a little too high in my amplitude, so you have to fold it back. You have to think of this. It has its limitations, subdivision. You can use pipe and variable pipe, but I've really chosen to push this a little beyond what I probably need to do for this. So if I had like 3 patterns or 2 patterns, then I could play with it in its full range of frequency and amplifications. But I'm just trying to create a more complex script and while running that subdivision node. Now, you're not going to run into that at all if you're happy just viewing the lines and you're starting to build some complex scripts. You'll see how tricky and wild that can actually get. So you actually have a pretty awesome type of lattice work that you can name yourself, you can simplify it, you can do whatever you want. But if you want to go back to what it was initially and you want to find that subtle, nice form that behaves the way you want and don't be so crazy as me, then go right ahead and do that. So what we're going to do now is with the multiple iterations of it, I don't just want to bring it into subdivision to end. We're going to save that for the final draft. I want this form to, as many times as I make it, 5 times, I want it to rotate evenly around in a sense of 2 pi. I want to do a rotation. So in preparing for that, I am going to grab all this data. I'm going to copy it and bring it down here. I'm going to anticipate prompting a rotation node, and I'm simply going to cut the script, try and have good practice so people don't get so bored listening to me. I'm going to prime it with a hash key. It wants to turn it into curves, but it also, with a prompt, I want it to do it with rotations and stepping up in the Z direction. So let's see what this monster will generate me as a single node, and you'll see how it's learned by itself. It's advanced. I've trained it kind of. It's going to write my final script. I understand it from the base up, and we are going to take off the comments, and we are going to prime it with an @ symbol because we're ready for the hops component. We will name it whatever it chooses to name it, and it might need a prime. And if it needs a little primer, look to what you need to type, hashtag lattice trig curves 2, but we are going to do lattice trig curve rotation -1. So you can see how your functions get more complex. Names it, tells us what it's going to do. Inputs, they should be very similar to our last set. Everything seems to be running right. I should get an amplitude as an item. I should get a frequency, and I should get a rotation. I knew I was going to get something because of this little comma that's sitting over here. I know it's trying to give me something more, and I'm a little curious what the more would be. So enter. And it says you need a step up in the Z direction. So I don't know if I want to do that yet, So I'll save that for somebody who wants to put that in next time. So I'll probably put it in there, but just because I don't want to lose the data, I'm going to remove that that comma there, comment this out, come down here and end it. So I might do the step because my prompt told it to step up in the Z direction. So of course, GitHub Copilot is trying to step up in the Z direction. And I just like to say this is one of my best videos I've made, and I hope somebody benefits from this, and I'm very proud of myself right now. Anyway, I'm trying to slow down. I'm trying to listen to what people want, and I'm trying to build a blueprint that can do anything. So the concept of lattice work really makes sense to me, because there's so many companies that focus on that. For additive manufacturing extrusion, for filler, for printing. There's so many applications of gaining control of your own lattice structures with a few lines of code. As far as I'm concerned, this is when the code is going to start, right now. Definition. I have more arguments coming into it. It is thinking, which is a good sign. It's importing the math. It knows enough to comment the points. It's going to produce those points. It knows enough to go in and produce the curves. And it knows enough for my spacing that I want to have another rotation happen in here at 0, 1. I'm so happy that it wrote itself. I don't have to debug it so long as when I hit Control S to save and F5 it runs. Now I get to visually see what's happening. Let's grab it. Let's grab our one hops node. Let's double click, put the path in. Let's put the lattice, let's do the call name. It's usually the same. Let's put in the call to the function. Let's name it that. Let's put the call in here so we're not making horrible Grasshopper scripts that don't tell people what to do, but make your Grasshopper scripts easier by doing this. So let's put that in, and there we go. Let's keep it simple. Something recognizable, 10 by 10 by a 10 amplitude by a 6.7 frequency, not this rotation. And the rotation, I want to have a rotation that goes from 0, 2.00, because I want to deal in radians. So I want to have a pi node that I filter it through as a factor. And let's just have it rotate through recognizably. Let's do edit snapping and have it go through at 1 pi. You could have it at 0.5 pi and 3 half pi. So that'll snap right on the 1. Let's put that into here. It's running. And now what we'll see different is a single rotation, which makes total sense. A single rotation over here by 1 pi. So once again, let's take that, put it back. Let's either do a full 2 pi rotation or 1 pi rotation. Let's do the full 2 pi rotation, and let's use our brains, take this through the same amount of steps into the domain, and put that in there, and now we're able to see 2. Now we're able to see 3. Now we're able to see 4. Now we're able to see 5, 6, 7, 8, all the way up to 10. That's a pretty complex lattice. This one's kind of nice. And you can see that you're gaining control of some very cool geometries. And it doesn't have to be that whole way. And you'll see you have your 5th one coming over your 1st one. So that's a little bit of a little trick there, that this is counting this range as I put it in the frequency. You see what happened? That range will come in as 5 frequencies, and this one will come in as 5. So it's a good practice on steps. As you're counting 4, it's good practice to have an equation in here. And I'm going to just do it here under the expression node, x minus 1. And I'm also going to put it in this one as an expression, x minus 1. It's just something you have to consider working with ranges as you get into series. And now we have 4 items coming in and 4 coming in. So when I put in 4, I get 3. But when I put in 4, when I put in 5, I'm actually getting the 4 that loops around and it changes. So I think so. Hang on a second. No, I'm still getting my 5. So it's very interesting. I got to think about my little math a little bit as I do that. I probably could bypass that. Let me go back in here. Take off that. I'm not going to need it. I'm just going to have it step up from the first one through to the second one. I'll leave it for now because it's a minor thing to work out later. But I am going to pull up all of my meshes like this through a 2 rotation, and you'll see you have this pretty awesome unit that can be changed, and it has to update through that full rotation and through that full range. You've got a pretty complex piece of geometry that's a 3-dimensional lath. Nothing's changing the frequency when it's flat, but you can see you can have a very subtle use of this. And I am curious if you ever wanted to build a wonderful kind of staircase as to where the guide would go. You cannot take panels and put them into components in Grasshopper 1.0, but you'll see here at 580 milliseconds, we've got a pretty awesome lattice that's been constructed and not that slow to actually update. So as we move this maybe higher frequency, we can kind of generate some pretty cool stuff. And it's got that little slow down, half a second. And if it does get too slow for your lattice work, then you'll probably want to take your solver off. But this is looking pretty ugly now. I've kind of pushed it a little farther than I would have to do. I think it's because there's so many of these. It'll get faster as we come down. There we go. So I've got this kind of 4x4 lattice that's changing as it goes around. I could eliminate and call out my first one if I had to. I'm just kind of thinking while I'm going here. I'm not totally happy with this model. I do think this makes things weighty, so you should take it off until you get the geometry that you want. And I think I'm okay with maybe that surface, and I don't mind it going up to like 6 or 7, or actually 7's a good number. 6 is more readable as a hexagon, so that's a kind of interesting device. That would be a strange lattice work, and I can always pull that back and have it only go around a little bit. But the only thing is this still is operating on a pretty, on the one construction plane. So what I'm going to do here is take it to 2 rotations, and I didn't carry my script here last time, but I'm going to save my subdivision till the end. I'll finish here because the tutorial is getting a little long, and now I'm into new territory, which is totally fine. I know I'm going to have one more parameter driving this. I'm going to downsize the Rhino, and I'm going to go back into this, but what I want to do is I want to utilize that step. And the best way to do that, and here's an example of cutting pasting script, which you're recommended never to do. But let's copy it and let's clear this. Let's go to clear. And let's go down here, and in under 200 lines of code that's finished this, we'll change this rotation to 2, or we could change it to B or whatever. I also want to make sure I'm on the last one. I want to change this to, and we'll have to change more than this, to 2. I do want to activate the H, which means I'm going to be missing a comma here because it's a listed of inputs. I have to edit this down and get rid of it so it brings in that step, which it will do for me. And now I may want to consider where that step will be introduced. So I'm going to carry it back to here. I'm going to actually let it write its full self again, back to point list. Let's see what it generates. So let's see how it differs. Tab, enter. Honestly, it's as easy as tab and enter. No step yet. Create the list of lines. I'm sure it'll deal with the rotation script. Curve list is generated. Let's take it through its range. Size -1, and you can play with any of this data within here once your script's running. And what's nice is Copilot will really produce things that aren't hard-coded. Here's your rotation. All vectors being created. Did I create vectors last time as I look ahead? I did. And we should have a step up of the curves. So let's see if the length of the curves work. Let's see what it wants to do. It throws a step in on the end. It's choosing a translate. We could run into problems, and if we do, it takes me to the next stage of what I'm doing. I know this one might run. It might load. It could hit a red flag. It didn't yet, but usually the red flag comes as you try and pull this out. So we'll pull it here, and I'll either have this in blue that my final script worked, or I'll grab this and I will put in my rotation 2. I will change this to rotation 2. I will change this to rotation 2, and I do this for good luck because I always hit bugs. I know this one's going to use this URL, same URL. Keep in mind that you can be sending yourself functions from other running scripts or anything that you put on GitHub Copilot. You can become 1,000 U's when it comes to being a programmer. It's actually pretty tremendous what I think psychologically is happening in the minds of people trying to build these things. If we get lucky, we'll get lucky. If we don't, and there's a problem which somebody may foresee, I'm going to keep my frequency simple to start. I'm going to keep my pi easy, and my steps, I'm going to keep it to my same digit steps of 6. It worked. Let's see if it transformed my geometry. Let's take a look at the visuals because that's what I'm watching. And we still have that single one. There's no stepping. It looks like it's stepping out. You'll see that step, you'll see that step is just a step up. But that step itself can become the same range as the frequency, as the rotation. And if the step, just let me do a quick check, step is a hops number, so I'm not going to get botched in an integer value. I could probably use the same frequency for the step, and you'll see that if you don't see what's happening, I'm going to take that out, grab myself a secondary, the step's the same. I'm going to take out another factor here for the domain on the steps, just to see if that's independent of the other data. And you can see that it is producing a step up. So now I can go hard into editing, make this a very big number, and I can start to pull this up into the magic of what it wants to be, and a very interesting lattice spiral staircase in the end. And the reason I was seeing that initial form and playing with those numbers, it finally clued in on me that I have those lattice structures in every other documentation. I am so happy that this, now brought to here, becomes a subdivision tool that if I could throw a line through the join it, I have produced one crazy set of stairs from GitHub Copilot writing it for me. I can take all the visuals off here and everywhere in my script because I don't require any of this. I technically don't require any of this to even be working. All the visuals here can be taken to off, and I can leave this on that I am seeing parametrically what I am building as a script. And I didn't mean to build this, but that's just what came out of my project. I am going to zoom in on Grasshopper to this subdivision node. Actually, more importantly, I'm going to zoom in to my very simple trig rotation 2 that involves a step. I'm going to name that node, and I'm going to zoom in and say that script has parametric control to control all of this wonderful work that's here. Zoom extend all, and you've got a very interesting device that quite honestly was written. Let's take half of this, and I'm actually quite happy with the top view and the side view. Let me downsize this, see if I can pull that in. And you see that geometry from one call node is able to write this much code. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 for the math, and 16 for the definition. 16 lines of code generate everything you need, and that's all you need to run with a hops component. Call it wherever you need it, and it will build this incredibly parametric, fun, undulating lattice work staircase that you can play off of what you want to do. And it moves fairly quickly with that subdivision. If you put that to mesh pipe or even to a regular NURBS pipe, we could try that as well. But I'm not going to bother with it because those are older tools. But I definitely think that's the gist of this demo. I hope people watch it. Please support me if you're interested in this. Go to WICKERSONStudios.com. I sell 5 years of research and development for $9.99. Everything I do it to distribute, and I do to find out people's points of interest. It's also a place that you can download all of the research, and these are micro fractions of a cent for each script. And I'm just basically giving it away, but I do like to watch Google Analytics. I like PayHip. I like to know where internationally I'm having an influence. So those few pennies you have to pay for bundles and bundles of scripts and hundreds and thousands of lines of code, hundreds and thousands of lines of code, that's well worth playing with. And you can always go in and pick a bundle that's more for you, which would be the beginners, the intermediate, or the advanced. I'll let you know right now that all advanced nodes on there I try and make available for development, work in process on my GitHub. So thanks very much for watching. Michael Wickerson at Wickerson's Studios. This was a project about creating lattices with Copilot AI into Grasshopper for Rhino 3D. And I think what I'll do is I'll take a little screenshot here. I'll wrap up my recording process. I'll stay live for a minute